Welcome everyone. In the final project today I want to introduce you to an important program, the program which we will simulate our final project on. The program is called ITS PLC MHJ edition version 1.1.3. First thing, the system menu. We have here multiple projects such as sorting, batching, polarizing, pick and place, and automated wall house. Today we are going to design polarizing project. The polarizing project, we have manual and the automated section. For manual section, we have here some sensors, about 10 sensors, and have 7 actuators, 8 actuators, 0 to 7. Let's get through the PDF of this project. Palletizer project, we have here the cross section. We have here section of polarizing project, how it's work, and here we having the sensor and its name, and we have the actuator and description of each actuator. Let's start. First of all, we are going to use TIA Portal version 13. Let's create new project. ITS create. Configuration device, add new device, controller. We will use S7300, CPU, S7300C 2DB. Let's use this one. Okay, this is the configuration device of S7300. We have 16 input and 16 output. To change we need to change this digital input and digital output to start from 0. And the output to start from 0. Then save. Now we are going to detect the tags for each sensor and each output. First of all, we have 10 sensors. Sensor 1, that's for input 0.0. Let's call it sensor 0. And sensor 1 for input 0.1. Sensor 2 for input 2, and sensor 4 this is 3, four. Let's copy this part. 5, 6, 7. We have 11 sensor from 0 to 10. Sensor 8, 9, and sensor 10. Now let's get to output. Before getting to output, let's design the start and stop buttons and reset button. From the datasheet, we will find that start button is for input 1.4 and stop button is for input 1.5. Start for input 1.4 and the stop button for input 0.5 and reset button for input 0.6. Now let's get to output. We have multiple output. First output we have here case elevator, in this case elevator, this actuator is used to bring this box up. So the first actuator will call it lifter. That's for Q0.0. And second actuator is used for the cursor of this elevator, so we'll call it cursor. The third one is holder opening. Holder opening is used for this blanket. Let's call it holder. And the third one is called format advancer. Let's call it mat. That's used for this mat. Now the fifth one, packet route advancer. Baking route advancer is used for this one. Let's say called packing. First one, for ascending movement of the pallet elevator. That's the elevator. That's for ascending and this for descending. Elevator up, elevator down, and the last one is used for conveyor table. Conveyor table that one is converted to take mat from this box to get okay, let's start. What we need from this project: take mat from here, get it up, and get 6 boxes from this tank and bring these boxes and bring those boxes down here and took those boxes to this place. So let's start. First of all, we are going to need program block OB1. First of all, we will need start button and marker used to continuous operation. That's for input 1.4 or start button. That's for stop button. That's marker, let's call it M0.0, used for continuous operation. M0.0, let's bring it down. First of all, if the sensor 6 the sensor detecting this mat or the elevator being down, means When the elevator is down, the sensor 6 will detect 1. So, if this sensor 6 detecting 1, set a marker called set that's for set coil. We are going to use set coil. That's here, and that's one, put it here. We are going to use it a lot. Set marker called M0.1. And the M0.1 will be resetted when the sensor 10 detects. Sensor 10 input 1.2. The sensor 10 is this sensor. Is used for this mat to detect the mat at this position. Let's see. We need to stop the mat at this position. So we are going to reset by sensor 10 this marker, which was called M0.1. Okay. If M0.1 is detecting, means the elevator is down, we are going to operate the lower conveyor to take the mat on the elevator. The lower conveyor is Q0.7. All tags, show these tags. This called lower conveyor, mat conveyor. Okay, let's return. By M0.1. Okay. If we already start and we are at down position of elevator, we are going to operate the mat conveyor. Okay. And if the sensor 10 detects M0.1.2 sensor 10 detect, add negative edge position, that's for previous. In 1.2, and this called by marker, whatever the marker, let's say in 10.0, we will reset another marker called M2.0. Leave this alone for now, and we are going to use input 1.2, the sensor 10, for another marker. That's for M2.0, and that's for M0.6, and that for M0.1. okay, that's for the M0.2. let's say if the sensor 10 detecting and sensor 6 is detecting at the same time, we are going to set this marker. Sensor 10 is this sensor and this sensor. This marker, this means we are going to bring this elevator up. This marker is used to bring the elevator up. But where this elevator should be stopped? At sensor number 7. So we are going to use sensor 7 to reset this marker, which is going to bring the elevator up. This marker is used to bring the elevator up. M0.2, M0.0 is used for continuous operation after stopping. This is the first marker. That's for elevator up, Q0.5. We need to make sure the elevator up will never work with elevator down. So we are going to use elevator down here as normally close, Q0.6, and shouldn't be worked at the same time with the down made conveyor. So we are going to use make conveyor as normally close here. Okay, now the elevator will be up and stopped when the sensor 7 detects the elevator. Now if this sensor detects no boxes, this means we need to bring some boxes. So we are going to say if sensor to M0.2 take no boxes for a period small period, let's say seven second, we are going to bring some boxes through marker called M0.7. At the same time, we need to make sure we are already at start position, so we are going to use start marker or continuous marker as normally open right here. Alright, this marker is going to bring the lifter of boxes up, and we should make sure we are already on start position, so we are going to use M0.0 marker. And we already add sensor for detecting, means this sensor 4 let's see it, this is sensor 4, there is no boxes here, so we are going to use a marker called M0.3 as normally close. This one is for lifter Q0.0. This marker will be set by the sensor 0.0. This sensor means the lifter should stop because there is box right here, not down. That's used for setting the elevator or lifter, mean M0.3, and M0.3 should be resetted when the boxes come right here. Again, the boxes come from the down tank up right here. Then we need the boxes right here, so we are going to use the cursor to bring the boxes from here to here by using a marker, and the first marker should be resetted by after all this operation. So we are going to use input 0.4 to reset this marker, which is called M0.3. Okay guys, the Q0.1 or the cursor, this cursor which is used to bring those boxes right here like this, should operate when the sensor 1 detects the box. So we will say sensor 1 and sensor 0. The sensor 0 will make the cursor operate. So we are going to say the cursor should operate at sensor 0 when the box at sensor 0, and should be resetted at sensor 1 when the cursor is forward. The sensor 1 detect. See? Sensor 1 detect. Okay. Let's say this. Control X. Take this network before this network. Because we already first need to set the cursor and then reset the cursor. This network is up. Sorry. Control Z. Before resetting the cursor. So we are going to say paste here. Paste right here. Set the cursor first, then reset the cursor. The next thing we are going to do is we need two boxes on the bottom and two boxes on the middle and two boxes on the top. So we need two boxes at each time. So we are going to use counter to count the number of boxes. It will be counted by sensor 0 by the positive edge. Just like before, and this for marker. Let's call this marker M20.1. We are going to use counter up. This counter should count 2. So we are going to get the output MW30. When the MW30, so we are going to use comparator equal integer, so we are going to use comparator operation okay. We are going to use this comparator for MW30 and when this MW30 equal to, we are going to make a marker called M0.4 and we are going to set the marker called M0.3. The counter should be resetted when the input 0.4, so we are going to use M0.4 to reset this marker, or by reset button. Just for reset button. Reset button is input 1.6. Okay. Just use for 2. Okay. Reset value. Let's see. If the input of the sensor 7, input 0.7 and sensor 2 at the same time, we will need to set the mat. Upper mat. This mat. So if sensor 7 and sensor 2 at the same time, means the mat which will carry the boxes is right here up, means let's see where this mat is right here up. We are going to set this mat. But we need to make sure, so we are going to use safety timer at this position. This timer T#1 second. We need already make sure we are on start position, so we are going to use continuous marker M0.0 and use set for Q0.3 or the mat. The mat also can be set by sensor 1.0. So we are going to use this one and this one. First one, this one is used for input 1.0, the sensor 8, and the sensor 1.0 at the same time. Input 1.1. We need to use the marker M2.0 to make sure we are already going down. Means we will bring 2 boxes at sensor 7 right here. Then we are going to bring this mat down to sensor 8 and break 2 boxes over them. Then they bring this mat right here to sensor 9. Whatever, right here, and bring 2 boxes over them. So we are going to bring boxes at sensor 8 and sensor 9. So we are going to bring the mat 3 times at sensor 7 and sensor 8 and sensor 9. Q3 will operate. This man will operate after a small time, very small time. Let's say T has 300 milliseconds. We are going to bring Q0.2 or the holder down. We are going to open the holder. We should make sure we already on the start position. The start position, the start marker will be in series with each output. Input 0.4, the sensor 4, is going to set the baking actuator, and will reset the mat. Input 0.4, at input 0.5, and we should be at start position. So we are going to use reset to the mat Q0.3, when the baking is done means AQ 0.4 and M0.0 at start position. We are going to wait time on let's say T#6 seconds before resetting the baking. And setting another marker for another session called M0.5. Now the mat is resetted and the baking is resetted, means the boxes on the this mat. Let's again M0.5 we are going to use it for elevator down, but it should be resetted by input 1.0 and M2.0, mean we are going down M2.0 and add the sensor position, the other sensor position, sensor 9 and sensor 8. This down should be stopped. But we are going to use positive edge contact just like before. Let's call M2.0 and like after let's call M20.2. Okay, we are going to reset M0.5. Let's go. And M0.5 will be reset at lower position at input 0.6. So we are going to use input 0.6 lower sensor to reset M0.5. M0.5 is used for bring the elevator down. So we are going to use M0.5 to bring the elevator down. Q0.6 the lower elevator. We should make sure that we already at start position M0.0 and the elevator is not going up. and the mat conveyor is not operating, and the baking is not operating. Now we are going to use the sensor 6 M0.6 to set M1.1. And M0.7 to reset this sensor. This sensor say we are going up or down. At the end, we are going to use the reset button input 1.6 to reset the other marker. First one, M2.0, which is used for the mat, and M0.3. At first, if we are at between the up position and down position, we are going to bring the mat down. Input 1.4. We should to make sure if he already isn't going up, so M2.0 should be normally closed, and input 0.6 to make sure sensor 6 isn't already getting a signal, and M1.1. We are going to set M0.5, which is used to bring the elevator down, right here. We will need another thing here. Normally close M1.0. Okay, let's save this project and try to simulate it. Go to simulation and say run B. And let's download this project through, let's say, MPI, and we have here MPI, so we are going to use Profibus and start search. Let's say OK. Start search. We already have a CPU. Let's load it. We have some errors. Let's find this error, compiling error. First, at network 8. Network 21. Yes, this timer couldn't be right, so we are going to use another timer called like this one. T hash 7 seconds instead of this one. And this. What's the problem in this timer? Let's call it another timer. T hash 1 second, and remove this timer. And remove this timer and bring another timer. Let's call it T hash 300 millisec. Let's use another timer. T hash 6 sec. Let's download. There is compiling. Same problem for the counter. IEC counter, and this timer. This timer is called wrong. Okay, the problem is right here. Because we can't use set and reset coil for output in this position, so we are going to add another network and take this coil right here and use another marker right here. Let's say the marker is M100.0. This marker M1.100 will set Q0. M100.0 will used for this count Q0. The same for this one, as we can't use set and reset, so we are going to insert new network and use those branch. Here. First, we are going to use, let's say, this marker called M100.1. Let's delete this and this. and the timer will be used for M100.1. Okay, let's try to download this now. Okay, there is no problem. Let's download and start all and finish. The PLC in the current mode is stopped, waiting to download and starting up the PLC. It takes a long time. Okay, the loading completed. Let's go online.